a 3-particle state, for a 3-particle state is called the configuration. Like for this state, N11 is non-zero. The occupation number is non-zero, it is 3. So it's a configuration. Means all collection of all numbers is the configuration. And let me explain this a bit more, that what a configuration is. For example, now I start with this state and I just design 19, because here our number is starting from 1 here, then we are having 5, we are having 7, we are having 11, 13, 17 and 19. So I will put slots from 1 to 19, 1 being the minimum number here and 19 being the maximum number here. So let's start with 19 slots here, and this is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. So here I have 19 slots. And now out of these 19 slots, I just put numbers on them. This is 1, 2, 3, 4, 5, and 19. Now what is here, that all the 3 particles are in state 11. So 3 comes in here, while for all these slots I am having 0. And only 3 is here, so rest of the slots, they are unoccupied. And I have 3 here, and I will say that the configuration N11 is 3 here. Now if I select this distribution, this combination, then I see that one of the particle is in 5, so 1 here, and 2 of the particles, they are in 13. So here is 2. So I will have that N5 is equal to 1 and N13 is equal to 2. So N5 is equal to 1 and N13 is equal to 2. So the configuration number means the occupation number here is N1 plus N2 plus N3 and so on up to 19. So this is again the occupation number here is 3, because this plus this, while all the rest are equal to 0. Now if I consider this combination, now in this combination, 1 is having 2 particles, so 2 here, and I will say that N1 is equal to 2, while N19 is 1. So the occupation number, this is the configuration, and the occupation number N1 is 1, N2 is N3 and so on up to N18, they are equal to 0. And N19, the occupation is 1. So, okay, this N1 is equal to 2. So again, I have the occupation, the total occupation of this configuration is 3. 2 plus 1, 3, while rest are equal to 0. And now for the last combination, I have 5, 7, 17. So 5 is 1, 7 is 1, and 17 is 1. So I say that N1, N2, N3 and 4 are 0, and 5 is 1, and 7 is 1, and N17 is 1. And again the occupation number is equal to 3. So this way I will count that one particle is in state here 5, and I will say psi 5 is having occupation 1, psi 7 is having occupation 1, and psi 17 is having occupation is 1. So this way I will just, and this is one configuration. Now is we don't care that which particle is in which state, but we care that how many particles are in a state. So for that we come again here and we see that there is one way to distribute or get a configuration of 3 particles. And we are considering here the particles is distinguishable particles. So one way here, and this way we call one configuration. There are 3 ways to have this distribution. So we have 4 possible configurations, and out of these 4, I can say, if I consider the particles is distinguishable particles, then I will label them as configuration 1, configuration 2, configuration 3, and 4. There is one way to build this configuration, and that one way is that particles are in 3 different states. There are 2 ways to build the configuration number 2. 1, 2, 3. And again there are 3 ways to build configuration number 3. And there are 6 ways to build this configuration. And now we are in a position to address our basic question, which is this one. And here, out of these 4 configurations, we see that the 4th configuration is the most probable configuration, because the number of ways to have this configuration are more. There is 1 way here, 3 ways here, 3 ways here to build this configuration, and 6 ways here to build this configuration. So I will say that this is the most probable configuration in this system. And now we will address our basic question. And our basic question is that if we randomly select one of these particles, let me write the statement, if we randomly select one of these particles and measure its energy what is the probability? What is the probability Pn of getting specific energy En? That's our basic question. If we randomly select one of these particles, then what is and measure its energy? What is the probability that we will get a specific energy? Now, if the probability will be the highest, then we are addressing our question. That what is the probability that randomly selected particle has a specific energy? So we will calculate the probabilities, and then the highest probability will be the answer to our question. So let's start with the first one, with the distinguishable particles. And for the distinguishable particles, let me calculate here. That is the case of distinguishable particles, and here is the case for, we will first treat, as this is simple to treat the particles as distinguishable particles. So first start with this one, and the very first question that I have is that what is the probability, of getting energy E1. I want to find the probability of getting this energy. So, this energy is, I know that which configuration contains the particle in state 1. That is psi 1. And this is, psi 1 is where? Psi 1 is in configuration 3 only, because none of the other contains 1. So psi 1 is in configuration number 3. This is in configuration number 3. This is configuration number 3 here. So let me write like this. Now, configuration number 3 is out of the 13 possible combinations. So I will say that the chance of getting configuration number 3 is 3 over 30. Because there are total combination 13 and configuration number 3 is having 3 combinations here out of the 13. So I am having the chance of getting configuration number 3 is 3 over 13. Now in configuration number 3, I am inside configuration number 3 and the chance of getting psi 1 in this combination is there are 3 possible ways there, and in every way it is 2 here. So 2 over 3 is the chance of getting psi 1. I am having 1, 2, 3. So out of these 3, I am having 2 here by 3. So let me write the chance of getting particle in state psi 1. The chance of getting psi 1 in configuration number 3 is 2 over 3. Here is 2 over 3, 2 over 3, 2 over 3. So I am having the chance of getting psi 1 in configuration number 3 is 2 over 3. That is, only 2 out of 3 particles will be in this state, and in the state psi 1. So the probability of getting E1 is a result of randomly measuring energy of one of these particles will be P1 is equal to the chance of getting the configuration 3 is 3 over 13 multiplied by the chance of getting psi 1, 2 over 3, and this is equal to 3 will cancel, and I will have 2 over 30. So this is the probability of getting a particle in state psi 1, which is 2 over 13. And similarly, I can calculate the other probabilities, and the other probabilities, for example, I want to calculate the rest of probabilities like P2, P3, P4 and so on. Now here I see that the chance of getting, let's start with P2, and for that I will get to energy E2, and the state will be psi 2, and I see that there is no 2 involved here, so it means that P2 is equal to 0. And what about P3? I have no involvement of P3 as well, so P3, P4 equal to 0. P5 will be 0 or not? No, because I am having involvement of 5 here and involvement of 5 here as well. So now I do calculate that what is P5. I will calculate this one. So P5 will have state psi 5, and now in how many configurations this 5 appears? It appears in configuration 2 and it appears in configuration 4. So I have the configuration number 2 and configuration number 4 here, in which 5 appears. So what are their respective probabilities? In configuration number 2 here, it is having 1 over 3 because 5 and this, so this is 1 over 3 here, 1 over 3.